You're live, Scott.
Okay. Well, good afternoon, everybody. We're excited to have you join us for our first webinar. Um, our webinar today is talking about harnessing the power of interconnection. And we have Greg Elverstad. If those of you who don't know Greg, he is our in-house electrical engineer for Whistling Consulting. Greg and I have been friends and co-workers for, was it about seven years or so, Greg?
Coming up on 10 years, boss.
Yeah, okay, 10 years, right? We worked together at Vivint Solar. He worked on the electrical end at Vivint, and I worked on the structural end at Vivint. We built out some departments there, and we've been working together for at least the past couple of years. He's been on board with Whistling Consulting. He's got an extensive background, 4 years experience in power delivery sphere. He's worked for some utility companies. Got 23 years of that experience came from employment with two power companies, one in the Midwest and one in the Mountain West. He spent 6 years working for two power companies, subcontractors, covering projects from Western Illinois to the West Coast. His experience covers all ranges of power delivery of a voltage from 2400, 4160 volts through 500 kV. So he has extensive background, probably more than anybody in the industry as it relates to interconnection and working through that process. If those of you who don't know Whistling Consulting is the largest solar engineering company in the industry. We cover roughly about 18% of the solar industry in the residential realm comes through Whistling Consulting for engineering. We have in-house electrical engineering department that Greg runs. We have an in-house structural engineering department that is run by Heath Harpster. And we now are doing designs in-house, including commercial designs as well. There really isn't anything that we aren't able to take care of for our customer base. So anyway, we're looking forward to having many more of these webinars. And we're going to look for you guys to maybe provide some feedback on what would be some good topics that we want to discuss. I know that there's probably the next topic. I'll probably lead the discussion on that. And it's going to be somewhere in the realm of talking about AI as it relates to engineering and the industry, and maybe roof connections. Those seem to be issues that continue to pop up on some of the newer technology that's out there for connecting the roofs. So anyway, we appreciate your guys' participation. We welcome visitors. We welcome our customers who may be on the line. But I'm going to turn the balance of the time over to Greg so we can get started. I know everybody time is valuable, so we want to keep our discussion as brief as possible and probably spend more time opening it up for question and answers. So Greg, would you take the lead?
Thank you, Scott. Good morning, good evening, good afternoon from wherever you're talking to us or watching us. Appreciate your time and enthusiasm and interest in renewable energy. The title of the webinar is not accidental, Harnessing the Power of Interconnection. I want to touch base on the first thing that sometimes gets missed. What do we do in the solar industry? We make electricity. And yet it is oftentimes the thing that gets taken for granted or let go by the wayside because everybody's wanting to make sure that the modules can be mounted safely on the rooftop. Thus, guys like Scott and Heath do that. And it's important that that is validated and rectified. Because, for example, you've got places like Miami-Dade, Florida, where the wind speed requirements are in excess of 150 miles an hour. Kind of important to make sure that they are interconnected to the roof solidly to survive a hurricane. But once it gets off the roof, what do we do with it? Got to plug it in somewhere. So we got to figure out what is the best way to interconnect. And for those of you who have electrical experience as electricians or engineers, challenge you to prove me wrong in this statement here. Nothing will expose your weaknesses to the electrical code faster than trying to do residential solar. True or false? I'd love to hear your comments on that, but that's what I found. Like Scott said, I spent almost 3 decades working for power companies, so I thought I knew electricity. Truth is, I've been playing with electricity for nigh on 5 decades. Still don't understand it. It's okay. I know it works. You've seen it work. So we want to make sure that we can plug this stuff in and get connected correctly. I was hoping to share something real quick to see if this is going to work for me. Here we go. It will not. Okay, I was going to do a little sound bite, but I'll save you from that pain. So, want to look at something real quick here, just to get you a feel for what are we talking about. What are we looking at? We want to figure out how in the world we're going to get connected. So let's take a look at this one here. Sizable system on a house. Oh my gosh. First time you see one of these, you're going to freak out, right? That's okay. That's what we're here to talk about. But you've got a lot of stuff going on here. You've got a big boxes, large meter, all kinds of stuff, and obstructions. Yay. All of that's relevant. In dealing with solar, interconnection can happen in 2 ways: supply side or load side. Now, when we talk about supply side, you may have heard the expression line side. Feel free to use those interchangeably. They mean the same thing. Line side, supply side is simply a reference to where the renewable system is getting interconnected on a building in relation to the main disconnect for the structure. Not the same thing as relates to power companies' understanding of line side and load side. They're always concerned about anything getting ahead of the line side of the meter socket. Most companies out there do not permit that kind of an interconnection. There are a couple of them out there that do. One down in Texas, New Braunfels, Texas, wants PV interconnection to be connected ahead of the customer's consumption meter. The other one is state of Connecticut has a participation, I hope it's Connecticut. Anyway, one of the northeastern states has a participation program where you set up a second meter set for interconnection, again, ahead of the utility meter. We're not talking about that today. Just want that to be something on your radar in case you see that. Don't get freaked out too badly. And also, the opposite side of that disconnect, on the customer side of that disconnect, we want to identify that is a load side. And with that in mind, we now have the wonderful challenge of figuring out just how do we connect supply side or load side. So let's take a look at an example of a supply side connection. Get one up here and get myself over to be able to pull this up on the screen for you. There we go. Get out of the way so you can see that and not look at me. Sharing the photo. So supply side means that there's nothing to turn off the power that you're connecting onto, the power connecting conductors between the meter and the home. So for example, on this screen here, you'll see there's a meter here on the left, and you've got some circuit breakers up in this area up at the top. But the crucial part is right here in the middle of the screen. You see these black bars bolted to the bus bar here, the power distribution bus bar. This is the supply spot. Now, you see these 3 breakers. Well, they say, well, that's the disconnect for the house. Well, not necessarily. It is a disconnect for a load center, but it is not a disconnect for the service. There is nothing to turn off the power between a connection here and this meter socket short of pulling the meter. That's the definition of a supply bus, where your interconnection capabilities is equal to the rating of the service. Sometimes you'll have authorities having jurisdiction who don't understand this or have never seen this, and they tell you, well, that doesn't fit the 120% rule for bus loading. And you have to back them up and help them understand that, yeah, where do you turn this off? You can't. That's why it's supply side. Same thing as if this was just a sub panel with a main breaker and there were wires leaving here going to the panel, and you had a way to connect to that bus bar. So that's supply side. How do we connect on that panel? You use a breaker. Now, there's another example of one that I want to cover briefly that you may see, depending on where you are, is one like this. Now, this one here is an example of a code violation. So make note of this. The breaker handle is upside down. That's not permitted anywhere in the country because that was a violation since about 1973. But the other thing you want to be careful about is looking at this label right here. Use only this type of breaker. Well, this model breaker, you can check that later, physically takes this entire 6-inch space right here. You can't have a breaker in this position here if you're using a QN style breaker because it occupies the entire width of that space. So that's a code violation. But I wanted to use the panel to show that you are able to have a breaker here feeding load and another breaker here feeding load, or if this is empty, you can park solar there. So make sure to make note of questions you might have as we go along here so that we can bring those up and talk about them as we proceed. Supply side also has a rule effective the 1st of January last year, 1/1/23. If you're going to do supply interconnection on the supply side of a disconnect for a dwelling, the connectors you use must be listed for use on the line side. Now, that's been something that has been in the works for about 5 years. And finally, it is actually a thing now, and jurisdictions are being made aware of that or waking up to that fact, and they're checking you. So be sure to check your connectors to make sure that they are actually listed for use on supply side. I will refrain from using specific manufacturers, but I know there is one out there that has that certification. They had the market for the connectors for a very long time. They still do, and now their connectors, including an insulation piercing style, are listed for line side use. If you want to get with me afterwards privately, we can talk about that. I have no stake in any companies for the products that I recommend. It just won't give them free advertising. Love their product, but I'm not going to give them free advertising on our webinar today. So anyway, the other balance of the time here is how to do load side connections. And I'm going to step over to our drawings in order to talk about what's going on and how these things get done, because I have about 24 different drawings for interconnections. Thanks to teammate Nick Seppi for bringing these all up for me to be able to present today, but there's a ton. So I'll step into cycling through these so we have a chance to talk about them. First one on the screen, you may have seen this one. 400 amp service panel with 2 slots, one not being used, one being used. Use a supply breaker. That's an option. And this one is just like that panel that I showed you earlier, with no breaker, turning off the bus bar, and capability of having 4 circuits on it. Solar connection right there. Very simple. Again, supply side. And another version with multiple ones. There are different panels out there. And moving now to load side. Why is it load side? The thing to look at is where's your meter? Follow that to the distribution capabilities in the dwelling. Are you going to encounter an overcurrent device? Yes, a main breaker. If that exists, you're on the load side connecting to the dwelling. This drawing represents a meter main. No bus bar outside. You just got a circuit breaker and a conductor going inside. There, you don't have a rating of a 120% rule, 705.12b3 332, excuse me. The 120% rule doesn't exist because there's no bus bar out here. It's very important to understand that the 120% rule of backfeed breakers only applies to the panel that can distribute load more than just the feeder going to another subpanel. So load side tap is a good way to connect. Rule out there says you have to be concerned about the conductor capacity from this point here down to the subpanel. Why? What you have is you have the capability of delivering power from the utility through this 200 amp breaker, and your PV source coming through this side to this tap point, let's just call it 40 amps for simplicity. All of a sudden you have the ability to deliver 240 amps down here to the loads. And the brilliant code making rule making teams figured out, well, there's two different options here. A, we got to worry about this chunk of wire being able to handle 240 amps. Not practical. The reason I say that is because most homes, probably 99.7% of the homes in the country, had subpanel conductors sized to this service rating, 200 amps. Well, guess what they used? They didn't use wire rated for 200 amps. They used 1/aught aluminum or 4/aught aluminum or 2/aught copper. Neither of those is actually listed for 200 amps. So then they said, okay, we got to protect that wire because it's like I said, it's only good for 180 amps if it's 4/aught aluminum. And it's impractical to rip it out of the wall and stick in wire large enough to handle the sum total of the PV plus this. Well, what do? They said, well, what if we choke it? We shut it off at the rating of the wire, in this case, the service wire, at 200 amps. Now, no matter what the house draws, it's only going to draw 200 amps. No matter what the PV delivers, it's going to deliver its stuff, and everything is safely protected. You got to be worried about that. Another option, I want to point out the difference between the two. Where are we making the tap? We're making the tap outside versus making the tap inside. Well, why do I want to do that? Well, sometimes you just can't get in here, and you got to make a connection somewhere else. One of the other things that I want to make sure that you understand is the latest code, 2023, did have a stipulation on the distance between the main distribution panel and the remote distribution panel, that being 25 feet. So now you can still do the tapping like we said, but they want an overcurrent device ahead of it. I wasn't on the rulemaking panel, so I can't explain the why, but that's what it is. Another option, what are we showing here? Let me check the difference between these two. Not much difference. Again, tapping outside versus inside, multiple different combinations. Here is probably the most common one you've ever seen. Load side breaker. Interconnection, very, very simple. Probably 90% of the designs you ever do are going to be this. So you take the bus rating, 200 amps, multiply by 1.2 gives you 240. Then you subtract the main breaker rating, 200, gives you the ability to land 40 amps of solar safely and conveniently. Other different options where you have a feed through. Now we're going to pause this for one moment and show you the panel that this is associated with, because it's very, very important. This gets missed a lot. So bear with me for 1 second. I'm going to go get that photograph and show you what I'm talking about. It is a subfeed panel capable of having anywhere from 8 to 16 different circuits and the ability to connect. But don't miss this vitally important thing. Oops, that's the wrong panel. Let me get to the right one.
Greg, while you're looking for that, let me
There it is
just
right there.
give you a timeline here. So it's about 25 after. Let's try and shoot for being done at like 10, 12 more minutes
You
and then
bet.
open up for questions at that point, okay?
You got it. Thank you, Scott. And I'm getting close here. This is the style panel that I wanted to point out. This one here is vitally important to never miss. There's a clue. These big fat wires, get out of the way, panel. These big fat wires are a clue. That clue is there's another load center. Go find it. This panel is representative of this drawing. How can you interconnect? We have the ability to land a circuit breaker here, which is great because it's outside. And most installers, if you're honest, you don't want to go inside the house. You want to stay outside and do everything outside, standing on the ground, instead of crawling through crawl spaces or what have you to get to the other load center. Problem is, this wire has to be protected. How do we do that? And we can either land a circuit breaker here, or we can go put a sub panel on the inside. But this is the one thing I want to make sure of. If you have folks doing your surveys for you that are not necessarily trained surveyors, and they can be sales reps and they can be whomever, or even homeowners, help them understand that this is only half of the puzzle for your house. The rest of this system is at the other end of these wires. So we cannot forget that. In order to do that, you have to protect these wires in some fashion, and we've already discussed that. So moving to the next one here, another example of the same thing. Sub panel off of a feeder, just the same 120% rule, fed off of sub panel. Maybe the sub panel is convenient to get to. If it's on the opposite side of the house from the service, and that's where you want to connect your PV, you can punch through the wall and land on that sub panel. Another example, just the same thing. And let's see if there's anything else here. So yeah, I want to talk about this right now. Supply tap in an all-in-one panel. So that is translated. This is an all-in-one panel example. This is a great one to use again. The meter is adjacent to the left here behind this dead front. You have your distribution center, just like this one here. The meter, a dead front, a distribution center. Some people have been tempted to tap these wires here. Please don't do that. You're violating the listing of the panel by intercepting those wires and trying to connect solar on there with a fuse disconnect. These were never intended for them to be tapped. I will put one caveat on this. Underwriter Laboratories will recertify a panel that has had these conductors intercepted to a junction box outside of the load center. I have yet to successfully arrange for one of those recertifications to occur because they want like $3,000 in fees to come and do that. That starts approaching the cost of a service entrance replacement. So just wanted to give you food for thought. If you want to explore that, just because there's sensitivity to a dwelling or some such thing that may prevent you from doing an upgrade, you may want to consider that. It's just an option. Again, a supply tap. Transfer switches, another hot button. If you work in California, specifically if you work in Northern California at all, chances are very good that you may have seen someone cut in a transfer switch into a panel like the one on the right. What they do is they intercept these feeders, run them over to a transfer switch, then come back into the breaker and then go on to feed the thing. Again, a violation of the listing of the panel. Creative, and it does work, but it's wrong. So we can talk about that if you'd like, as far as what to do when you encounter that. But suffice it to say that solar production devices on the market today, most of them require you to be isolated from a standby generator bus. So this transfer switch represents a generator being able to feed the loads, or the utility to be able to feed the loads, and your solar connection comes in here ahead of the switch to keep it isolated from the generator. Solar Edge, for example, says if you do this, you lose the ability to ever replace a service or an inverter that might fail because it was interacting with a generator on the same bus bar. So please be careful of that. Now, having said that, many of the manufacturers today have integration with standby generators. Enphase does this, Generac does this, Solarc, and other companies out there that can do that. Not intentionally excluding anybody, just to highlight the fact that it does exist. They have done this. You must follow their explicit instructions on how to do that. If there's any questions at all, get with your technical support advisor from the manufacturer to talk about how to do that. It's possible to do that, but if it's just PV, please don't do that. Please don't try to connect with the same bus bar. And one last one I want to highlight. It's implied here, but there are companies that have a meter socket adapter that can be used for interconnecting solar. The big three power companies in California have their own, and there is a vendor nationally that also does this. This is a great tool to provide for solar interconnection should you run out of space or there are just too many loads on the panel to be able to connect the amount of solar that they need. So be aware that that is another option. A great option to do this. Okay, I'm going to dispense with that. Stop sharing, but I want to show my beautiful wife and give the screen over to anybody that has questions. We got some time here and we want this to be as beneficial to you as possible. So if you do have a question, go ahead and raise a hand. We'll call on you. Ben, we'll let you go ahead and direct things.
Yeah, well, if you have a question, raise your hand and then I'll unmute you so that you can ask the question.
Okay, I'm not that good. Please, you've got to have questions.
And it can be on anything, guys. Commercial, residential.
Indeed.
Yeah, Greg, why don't you take a minute and talk a little bit about the benefit of when you're doing commercial interconnection, the benefit of having a pre-meeting with the utility company to kind of, I guess, grease the wheels a little bit.
Okay, great point, Scott. So stepping over to the commercial one, a lot of you probably don't do a lot of work in commercial projects. The magnitude of the array can be huge. We're talking hundreds of kilowatts and even bigger. And they can have a significant impact on the utility company's infrastructure. So what we offer is the ability to have a conversation with the power companies and our clients to discuss interconnection capabilities and also understand their rules, because there's specific things that the power companies want in relation to how the renewable system will interact with the grid. Some are completely passive and they're fine with that. Others are more interactive and may elect to take advantage of stored energy. For example, if you've got significant storage on site, power companies are looking to take a benefit from that and request delivery of a certain portion of that energy at some given time, usually in the late afternoons when the demands are higher. But one of the things that we offer, like Scott said, I've seen both sides of the meter socket, been exposed to a lot of interconnections, both residential and commercial, and sometimes you have to get creative in how to interconnect. And it can be challenging, primarily because the result of trying to make an interconnection can be very expensive. So we want the client to be able to understand that going in before they proceed with the project and not wind up with a surprise come final inspection. Sometimes it can be pretty nasty. Some of my clients and I have had heart-wrenching conversations about the requirements that a specific utility wanted after the fact when it felt like things were good. And all of a sudden the game got changed at the final inspection point and significant rework was required. Those I've had conversations with, who they are. They're painful. So we try to mitigate that as best possible all the time. We're always striving for that, and we're pretty successful at that, even to the point of helping our clients save some money based on their initial choice of product. The manufacturers have varied capabilities, and so we can make some recommendations on what might be a better solution for them to minimize space, because as we know, space on the building is a coveted thing, and we want to make sure to best utilize that. Okay, other questions out there? Okay, we got some hands up. Jordan. Ben, you want to unmute Jordan? Or maybe I can.
I think you're
Hey
good,
there.
Gordon.
Yep, Jordan, go for it, Jordan.
I just want to say it's truly a pleasure able to sit on this webinar and learn from you. I did want to ask, you showed us an example earlier of a supply side potential connection on a panel's feeders that you said would invalidate the panel.
Yes.
My question here is there ever an instance where you could tap onto similar feeders on another type of panel and it wouldn't necessarily delist the panel?
That is a fantastic question, Jordan. I'm glad you brought that up. There is a product out there, Square D specific. So this is only for Square D panels. The Square D, the manufacturer, has a lug kit that is listed for use, and you connect it ahead of the main breaker. I'll try to find a photograph of that real quick. But basically, that would be a situation where you physically open up the cover, the dead front cover that's protecting the exposed parts. You loosen the connections, bolt on these conductor lugs, and then retorque that back down to specifications stated by the manufacturer, and then you can make your PV connection. It is a great resource, especially in a situation where a service upgrade is completely out of the question as it relates to potential underground feeder replacement. Specifically, I'm thinking of markets like in Sacramento, mandatory service upgrades in certain areas because the service conductors were not installed in a conduit and they were directly buried. And so their mandate is that you're going to replace this if you ever touch this service, and you're going to have to pay for the expense of digging it up and putting pipe in. This is a way to offset that completely and put the lugs in and make your connection, again, up to the rating of the service. Thanks, Jordan. Others?
Yeah, any questions at all? HJ specific, state specific. Even if you had a couple that were maybe project specific. All and any questions are welcome.
Right. I'll touch on a couple things, and feel free to interrupt with a hand raised. One of the things that comes to mind is certain jurisdictions not allowing supply taps at all.
Enrique has a question here for us, Greg.
Okay, let's go for it.
Go ahead, you're live, my friend.
Hi, I'm just curious. So I do a lot of work in California,
Yes.
mainly. And I've run into some situations where they don't really like load side taps, and I don't fully understand it. I know there's a lot of regulation regarding load side taps, but what would be the most thing that people are most nervous about when load side taps are mentioned? Just so I can kind of understand where they're coming from a little bit better.
Sure. Well, let's talk through real quickly the requirements. So the situation is you're tapping a feeder to put solar on. Typically, that feeder is a 100 amp feeder or larger. I don't like putting it on smaller ones. You can do that, but I try to stay away from that. So we're going to limit the discussion to 100 amp feeders or larger. Again, like I talked about, you have to be able to protect the wire from being overloaded. So the first thing you got to deal with is making sure that you have a proper connection that can handle the capacity of your source, 100 amp or 200 amp, whatever the feeder is from the utility company, and your PV. And typically the piercing connectors or even the Polaris lugs are large enough and hot enough or strong enough to handle the heat that could be there from both feeders. Then the downstream portion of it has to be protected one way or the other, either some total of the wire capacity, so 240 amps, for example, which is fat wire, or protect the feeder at its initial rating so that it doesn't get overloaded. And I think where the issue comes in, and I'm having a discussion with an AHJ about this right now, is misunderstanding what the code says. The code does not say that you have to size that feeder to match the sum total of, and by the feeder, I'm talking about the solar feeder. They misinterpret the code to say that feeder's chunk, your 40 amps, which by the way, you only need number 8 on. You do not have to worry about that being sized to the sum total of the 2 breakers. That 6 feet of wire does not have to be 240 amp rated. And some incorrectly misinterpret that and say that you need that big fat chunk of wire for that little space when that's more than the service is even rated for. Not sure if that totally gets down to
That actually really helps.
Just,
So it's more of a misunderstanding of the code reading rather than
Yes.
a misunderstanding of the interconnection itself.
right. So you got to make sure in talking with California, you're on the 2020, translate the CEC 2022, 70512A, no, B1, talks about 2 ways to protect the wire. Like I said, size it big enough or put a breaker on it. And then it goes on to the next one, that number 2 is where they get hung up. And that's not the wire. The tap is the connection that you're making. You go over to the feeder rules back in 240 for load taps, and that's where it gets you directed. So if there's a situation where they're still hung up on it, give me a call. We can work through that and help them understand that, because this is not meant to be complicated. And sometimes because it is electricity, or it's a newfangled solar thing, or a person has been around a long time and is pretty much as old as dirt like I am, maybe we don't get the training that we need to stay abreast of this and understand how it truly works. So it's a matter of the more education we can provide, the better it is for everybody.
Thank you. That actually really helps. Also, do you have any suggestions of certain things that a designer could look at to help them understand electrical a little bit better, or to add as training things that should be kind of necessary for a lot of people who enter the CAD space and doing plan set design?
Yes, there are several out there. Heat Spring specifically, Heat Spring website is one. It has a lot of good material. Then there are the national hero, Michael Holt. His materials are excellent. A giant in the solar space, Sean White, has phenomenal training. Another gentleman big in this industry, Bill Brooks. Sean and Bill work together have collaborated on a number of texts themselves. Great resources, wonderful program. There's another one out there, the North American Board of Certified Energy Practitioners, NABCEP, is an industry that is focusing on elevating the excellence of installers and designers and inspectors. Take a look at their website, nabcep.org, I believe is the website. They have a lot of great resources there. NABCEP Associate certification is a quick one that you can get. My colleague Jordan Davis and I are both NABCEP photovoltaic installation professional certified. That takes a little bit more training and exposure to get that done, but there's a lot of good resources out there. And if you run against a brick wall, message me and we can get you some more.
100%. Thank you so much. I'm definitely going to take a look into those. I think it'd be really nice to, at the very least, peruse over them and make sure I get the training out of them that I can. Thank you.
Anybody else have any questions? Okay, well, we appreciate everybody's participation today. We hope that this was helpful for you. Looks like Jonathan Alawas says hi, hi, Greg.
Said hi to Ben.
Yeah, so we're excited to be able to continue to do these. and we're going to try and do this on a monthly basis. So you can just look for some emails from our company like we did before with some email information regarding what our next webinar will be. If you guys don't mind, we'll probably send up a follow-up email to see if you guys can provide feedback as what your thoughts were related to the webinar and the content of it. Keep in mind, we're trying to keep these brief so we don't take a lot of time, and you know, having questions and answer are, I think, are even more important, because there may be a specific topic you have when you hop on a webinar that you want to ask, and maybe you don't even want to spend a half an hour listening to something. Maybe you just have a question that you might have, and so format we might change a little bit moving forward. But anyway, thanks so much for all of your support, and those of you who are in the industry, you know, stay with it. We're always a resource. Greg is available at any time if someone wants to reach out to him. Our numbers on our websites. You can reach out to the general number. His email, I think, you know, Greg, why don't you put your email into this chat so
Yes,
people
indeed.
have it, and you can always email him a question. And we love to help where we can and to provide resources to you guys in the industry. So,
Just posted that.
okay, no other questions, and I think we'll end our meeting here and look for some more details from us.
Thanks,
Any
everybody.
other last comments, Ben? Or
Oh, thank you. We appreciate it. I put my email in. Any questions you have or any ideas, we really, like Scott said, want your feedback so that we can make these the most productive for you guys and really help you out. Thanks
all
for
right,
being
guys.
here.
Well, thank you so much. Have a great day.